The problem is that it's not staying still long enough to cross the chasm, right? It's not stabilizing into a standard technique. We're moving on, so we're perpetually stuck on this innovation thing.
But you could kind of look at that picture and say, oh, I can see what's going on here. If you're building your own GPU, the GPU vendors are building their own cloud.
So is it a bubble, or is it perhaps a bit of a flywheel?
There has been a big diversification of the business plans of these companies. Most of them were pure Bitcoin mining. They're all going into hosting HPC and AI workloads.
Welcome to the Orion X Download Podcast. Join Shaheen Khan, the Orion X analysts, and special guests as they discuss and simplify the big ideas in technology that are changing the world. Thank you for being with us.
Hi, everybody. Welcome back to another episode of the Orion X Download Analyst Roundtable, fondly referred to as ART. And with me, as before, is Adrian Cockcroft, Stephen Perno, Chris Krull. The whole team is here. Gentlemen, welcome. But first, the usual disclaimer. What we are discussing here is not financial advice or really any other kind of advice. With that out of the way, let's go to the same method that we had last time. Adrian, you've been kicking around AI-aided coding, I guess, software engineering. Let's get an update on that.
Yeah, sure. This is an interesting area because the tooling itself is changing so fast that it's hard to keep up. And that's really very unusual. Generally, if there's a technology area, you start learning it, you figure it out, and then there's sort of you're building a platform that you can then use to go extend on top of. But the problem here is the platform is just disappearing underneath us on a kind of a monthly basis. You know, whatever you were using a few months ago is now obsolete. Things you built a few months ago are kind of throwaway. Let's start again. So that's what's making it particularly hard. And I've called this enterprise indigestion before. You can keep up with it if you're an individual or a startup, maybe. But for enterprises, it's incredibly hard to manage this level of change, basically. It's not something they're used to doing. I'm currently putting together a talk for the QCon San Francisco, an event where I've done quite a few talks over the years. The first real disclosure of what we were doing at Netflix was at this event in 2010. So I've been there a few times. And so it's on Monday the 17th. It runs for a few days, but that's the day I'm doing my main talk. And the talk is called Directing AI Agents for Fun and Profit. And there's a few key things in there. One is directing rather than managing or using or coding with, right? Because the skill set that I think you need to manage a team of AI agents is a senior manager skill set. You don't look at the code of the people that are writing the code for you. You're saying, this is an outcome I want. Go away and build it. So you're hiring development teams to go build things. And that's the sort of attitude that I'm taking with this system. You do still have to kind of get into the weeds occasionally when they don't do something right. But most of the time, you're setting a high level objectives. And then the fun and profit part. For a start, it is actually fun. I'm having fun coding. I'm building things ridiculously quickly that work. And then occasionally I get frustrated and something doesn't work. So I'm working out by playing, which is the fun part. Where's the sort of path of least resistance or the sweet spot or the highway through the jungle? And where are you off in the weeds and having issues? And that's changing all the time. Sometimes things that didn't work a few months ago are now just working all the time. So, for example, it's generally if you try to build something in Python, it mostly seems to work first time. That's been my experience. The further away you get from that into more obscure languages, the harder it is. I've also been doing some Swift development. Yeah, it writes syntax errors. It takes a lot longer. It's just a lot more clunky trying to get things to work in languages that are less mainstream. So one of the techniques that I'm talking about in this talk is to basically prototype stuff that you want to build in Python, get it cleaned up, get it built up, build the testing environment around it, and then say, okay, translate that to another language for whatever reason, Rust or Swift or something, right? Because then you're giving it as a very closed problem. It says, it can see, I have an implementation that works. I can see how it's structured. I just need to rewrite that in the idioms of a different language. And that kind of seems to be quite a profitable way of building stuff, which you can then take to production. So that's the for-profit bit. So you have fun figuring out new tools. And then once you figure out how to use the tools, you want to build something for real, for delivery to customers, kind of for the for-profit bit. But I think that people are trying to, if you just try and build the for-profit bit, you won't be you'll build things that don't work and you'll fail too often. So you kind of have to have this sort of back and forth thing where you spend really an unusual amount of time just trying to keep up, just reading LinkedIn and playing with the new tools and trying to figure out what the hell's going on. And then out of that, you can build the for-profit things really quickly because it doesn't take very long if you can build them successfully. So a lot of the time that it's freeing up is actually being spent just trying to keep up with what's going on. That's kind of my current sort of state of things.
So let me ask you this way. When I observe what you're doing and posting and what Reuven is doing and posting and, the circle of a few of you guys who I am able to track, it comes across to me that for a pretty good fraction of software, it's over. AI can do it, can do a good job of it. And only you know how to set it up and how to use it, how to approach it, understand the high frequency change that you mentioned, the software that is needed to set it up and organize it the way you said, because your interaction with AI is different. It's more, like you said last time, more for like a product manager than coder per se. Then it really works. But then you kind of go out there and there is a massive body of evidence that suggests AI can't do it. So I think this notion of there is a method to getting the result is an important thing. But is the high order bit valid? Is it basically over for a good chunk of software?
I think not. I mean, if you pick the right, anytime you're sort of working on something that's emerging, right, you can figure out like the leading edge of stuff that works. And then you've got the whole crossing the chasm, the standard Jeffrey Moore thing, right? So out there in the early adopter, you're figuring it out, and then it has to cross the chasm to be mainstream. The problem is that it's not staying still long enough to cross the chasm, right? It's not stabilizing into a standard technique. We're moving on. So we're perpetually stuck on this innovation thing. And if you're on the other side of this trying to use it, you can get some things done, but you'll be just frustrated a lot trying to get these things to work right, particularly if you try to do too much or you just haven't figured it out. So there's another good thing that happened recently. Steve Yegi and Gene Kim have written a book on vibe coding that goes through a lot of this in detail. And there's some good techniques in that. They've been publishing excerpts from that book. But the book is now, I think, finally out. And the trick with a book like that is to get it out before it's completely obsolete, but they've abstracted up to some of the good techniques. So you have to go kind of read their blogs and track along. But Steve Yegi is well known as an engineer in this space, and it's worth just following him and where he's at. So there's a few people that will give you kind of the hints for things to make this actually work properly. But it is still, a lot of the time you'll try something and it will just be, that didn't work, throw it away. You were trying something that was a little bit too hard, or you just got too tangled up in, or you hadn't thought through your problem sufficiently to get it to work right.
I just want to point out too that it happens quite frequently that you go to some website or you use some software and it's actually not all that great. It's a little buggy. It doesn't quite do the right thing, the user interface. So then you say, what am I really trying to beat here? Am I trying to beat precision software that is used to do automated heart surgery? Or am I just using, some software where it's buggy anyway? And can I beat that? And I feel like that's a much lower bar. And that lower bar applies to a pretty large chunk of software out there for which AI should be able to do.
Yeah, so this drives into something that looks more like an organizational change. And I did a post on LinkedIn around this as well. So if you think back when cloud came out, what we did was compute resources. We used to sort of buy them, have them sitting in a data center, and you had a capacity that sat there. And you partitioned it up in different ways, but you had a fixed capacity. And with cloud, we went to basically, I need 100 machines for an hour, and then I don't need them again, or I need a few thousand machines for a couple of days, and then I give them back, right? And the resources were then on demand. What I think we're seeing with these AI agents, the sort of end game for this, if you like, and we're not quite there yet, but this is where I think we're heading, is that your development teams are on demand. You fire up enough agents to write some code for long enough to do it, and that's a few hours, and then you give them back. And I need a different development team to develop the front end or the back end or a different language or whatever parts of the system I'm trying to build. But I don't have to hire all those teams and have them sitting there all the time. So what we've got is effectively developers on demand. So from an org chart point of view, you have to be able to figure out how to successfully manage a group of virtualized AI-driven developers for a short period of time to get something done. And then you just give them back. You're done. You stop consuming the tokens and go and move on to something else. So I think this is the sort of the organizational change. And then the question of, you still kind of need some developers on a longer term basis to sort of manage platforms and things like this. But I think we saw that with cloud, where the sort of DevOps community dropped back from being like racking and stacking machines to be building the automation that delivers this stuff. So I think we will still be having developers, but they'll be building the platform that creates the development capacity dynamically to get a thing built rather than building the thing directly.
You need a mnemonic for that, for your talk. Developers on demand. It could be Dodo. It could be Dada.
Dodo or Dada, either with it's either surreal or extinct, right? Depending on which side of it you are.
That's excellent. But what you're saying, Adrian, is very consistent with the future of work discussions as well. I was an advisor for CollabWorks. This is now some years ago, but they were one of the pioneers, in my view, of looking at the future of work way before it was a thing. And definitely the cloud model for human resources was viewed at that time something that could be very, very beneficial to all involved, including the humans involved. Because there are humans who really do prefer to have kind of a gig economy kind of a thing. And if you're not forced into it, it is a liberating, important thing. And what you just said aligns with that quite nicely.
I'm also seeing quite a few of the successful people using these agents are the older people that were developers many years ago, and they understand how to manage things to an outcome, right? And that's that sort of director VP level people are coding again and having fun doing it, and then going, okay, you understand what it can and can't do. But the retired people, maybe the old guys end up being the people that turn out to be building the stuff, because we kind of have that background of how to get stuff done. So I think that there's a new life in the old guys.
So this is a good segue into AI in general and the impact of AI on society and what we're seeing in the market. There was reports of circular funding in the AI world. Let's chat about that. Who has a perspective you want to share?
Well, I'll jump in here. I think in our pre-talk, Adrian was making some good points that I'll let him make here. But when I step back and look at this, because some people have been thrown into a tizzy around the fact that NVIDIA is funding, basically, they see it as funding business for NVIDIA. But if you step back and think about it, I think it's a good thing that what they're doing is they're very rich in resource and they're planting seeds all over the place for excess capacity, and then maybe that's excess capacity. But I think that ultimately, because the AI world is so rapidly changing, we need so many more efforts at creating tools and resources for people in all kinds of fields. And, I know that we've been focused on the data center side of things, but I still wonder about the use case that the folks out there doing medical imaging and other kinds of narrower focused efforts that need affordable resource to go do what they're wanting to do.
I was having lunch with some of our Exxon friends, and one of them was saying medical imaging, the radiology use case for AI. It turned out that it was so narrow that it would do really, really well for this like one particular sliver of a cases, and then it would just fail for others. And if you use that as an example, it's great. I mean, it was similar to the coding thing, is that, if it is ready to do X, then it does a great job on X. But if it isn't, then you have to go teach it. But also there's a cumulative impact that every day that passes is like one more thing that it can do. So even if it's not doing it in a formulaic, I got the pattern, and it just has to memorize and learn every one thing, after a while, it's learned a billion things.
Right. I mean, and those things are permanent.
Right. It doesn't forget.
Right. I mean, once you train it to identify a certain kind of sarcoma, it's learned it forever. So
maybe we could talk a bit about this sort of circular funding thing. And we've seen a few examples of this over the years. So I'm going to start with one which is a little less controversial, but just to kind of see how this works, which is that Amazon wanted delivery trucks, electric delivery trucks, and it put a contract with Rivian to build those trucks. It also invested in Rivian and gave them a big order, right? And then when Rivian went IPO'd, the value of that investment increased enough that it was way more than the money used to buy the trucks. So anyway, it was like $1 billion order, but the value of the investment was several $billion. So from Amazon's point of view, they created a supplier, funded the supplier, made them successful so they could deliver, and they have been. I was driving down Highway 101 yesterday, and there were like 6 Rivian Amazon delivery trucks all around me, as I ended up in sort of clump of them. So that's kind of fine. You're sort of priming the pump and you're getting a supplier to be successful. It's relatively common, but it's driven by an end consumer that wants to buy something. But the end consumer is also investing in their supply chain. So they're making money on the investment as well as getting the delivery. So what NVIDIA is doing is a little different because they're sort of pushing it rather than pulling. So what they're doing is I think they made a $100 billion investment in OpenAI, and OpenAI used that money to buy GPU capacity from Oracle, who bought the GPUs from NVIDIA. So that money comes back to NVIDIA. But then when OpenAI finally IPOs or whatever, that $100 billion is probably worth more than that to NVIDIA. So NVIDIA is making money on the investment, but it's also feeding its own customer, paying its customer to buy its own products, which is a little bit different. You're sort of inflating, it's a bit more like inflating a bubble than the example of sort of Amazon and Rivian. And I'm sort of I think a few people are uncomfortable with this. It's not illegal, but when you look at it, it's a bit circular.
Yeah.
Right. And it works because NVIDIA's got so much money that they can do this. And OpenAI, I mean, it's sort of the two of the highest value companies in the industry sort of circulating money back around and around. So I know what you guys think of that.
So I think you can do this because at the end of the day, you have a product that everybody wants. And that's the pro tip. Build stuff that people want to buy. Because if you do that and in your short supply, then a whole lot of stuff opens up that isn't the case if you've got excess capacity. But for a customer to invest in their supplier is common. For a supplier to invest in their customer is less common. And that's like what causes a bit of an alarm for people to say, hang on a second, is this just pumping itself? And therefore, there will now be a bubble that sooner or later is going to burst or get deflated. So the risk management part of it is very different. And I'm not sure it is well understood. But also what is happening here that doesn't happen on the other side is that you cause some of these public companies, their valuations go high. So you get outside money in, right? So it isn't just between the supplier and the consumer. It's also about other people, bystanders who want to invest in. So some fresh money does come into the system that I believe actually reduces the risk.
So is it a bubble or is it perhaps a bit of a flywheel? Because we know that infrastructure has a finite life. I mean, the CPU or the GPUs go stale. And I know that there's downstream uses for deprecated gear, but all of that infrastructure needs to be refreshed every so often.
And there's incentive across the supply chain to refresh it. Even NVIDIA was saying, please do not buy my last generation, please buy the next one.
I think the issue here is because you still have to have revenue to pay for this. So this is based on an assumption that OpenAI will eventually make enough money out of this capacity to pay for it. And that's the missing link right now because their actual revenues don't sustain the business that they're doing. But given that you're in a growth space, it's okay to lose money for a while until you hit something that you're in some sort of S-curve where you're investing. We're in the investment phase. So it is okay to do that, but it's happening at a very large scale. It's happening at the sort of the $1 trillion scale, whereas most of the times this happens at a lower scale. So if the revenue doesn't turn up, or there's some revenue but not enough revenue, because quite often we see this markets. I can sell you $1 for a penny. That's fine. Do that for quite a long time, right? But it turns out eventually you have to be able to sell stuff for a profit. So the question really is that's the worry. And Paul Kodrowski, who's been sort of analyzing some of these things and talking about it in a few different places, was sort of pointing this out. And then the other piece of it that was worrying that Paul points out is what these call these braggawatts investments, where you say, I have so many gigawatts of data center, and then now the people are bragging about them. And those are being done off balance sheet using debt, which potentially could become pretty flaky at some point. So it's okay as long as the bubble keeps growing. But if it collapses, there's a bunch of effectively kind of subprime debt or whatever that's going to come on the market. And we saw a bit of that in the dot-com bubble 25 years ago, where one of the outcomes of the dot-com bubble was a lot of investment in infrastructure, particularly networking, a lot of dark fiber, which the internet built onto in later years, even though it lost money at the time. So we're going to probably end up out of this with a lot of empty data center capacity and maybe a bunch of cheap GPUs, which are going to sort of fund the post-bubble economy at some level. Does that make sense to people?
Yeah, it does. And also, when it comes to capacity in general, like from upstream chip manufacturing all the way to data centers, and these are major investments. You don't want to do them until you actually have qualified demand or indications of it. And you getting it right is important. You can't just build it and then sit on it waiting for demand to happen. But what you could do is to like buy the land and not develop it, or put a shell in and not furnish it.
Building and not have power for it is the current version of that.
Well, that leads to like what you need to be able to do this properly. So you need dollars, but you also need a location. The location is important because it dictates how you're going to get power, how you're going to get cooling, how you're going to get heat out. And then you need allocation of capacity, chips, systems, all of that. And that is also not trivial because for some items, you have to wait 52 weeks before you can take delivery. So that is basically another page on the spreadsheet before you can even put the money in for real. And then once you do that, you need to have construction, you need to build it out, you need to stand up the systems, and then you need ongoing customer demand. So there's a lot of pucks that you're skating to use the analogy, and all of them need to pan out. Now, if you have $1 billion backing you, that helps, but that part also needs to be pretty tight. So the whole thing is becoming really complicated.
Yeah.
Is like, 2 years ago, it was a lot easier. If I just had a bunch of GPUs, I could go get the electricity and I was good to go. Now, as data centers go from square feet to gigawatts, it becomes a much more difficult thing.
And I think there's also the time delay issue here, because when you've got an excess of demand now, you get an overbuild into the future.
Right.
So at some point in a year or two, these data centers will say, okay, finally, I've got the machines, I got the power, and we'll have an overcapacity possibly. And that's when you get the failures start happening, because the supply and demand come back into alignment. But so far, the demand has been ahead of supply, and that's continuing to inflate this bubble. So that's kind of, there's a few different ways this could, the bubble could pop, but maybe that's for a future discussion.
Right on. So the other aspect of this is the so-called neo clouds, or GPU as a service clouds, that are different from the traditional big cloud providers, Amazon, Google, Microsoft. And these neo clouds are a lot more tightly aligned with NVIDIA. I think there are now a couple that are tightly aligned with AMD. But you could kind of look at that picture and say, oh, I can see what's going on here. If you're building your own GPU, the GPU vendors are building their own cloud. And these neo clouds are pretty much captive with the GPU vendors rather than building their own GPU like all the big three are doing.
Yeah.
All right. Maybe this is a segue into crypto land. There's a lot been going on in the world of cryptocurrencies and Bitcoin. Bitcoin is down. Zcash is up. It's about the time of year when, Steve, you put out your report twice a year. You want to give us an update?
Sure. And, it touches on AI and HPC as well. We put this report out twice a year, and we do it in conjunction with big HPC conferences. Obviously, SC25 is the one that we do in November here in the States. And then in May and June timeframe, there's one in Germany that's really a European-wide conference. So we have another report then. This will be the 15th report that we'll put out later this month. And so we've been doing it 7 years for now. So we've got a record of how things have grown over the 7-year period. And as you can imagine, it's quite substantial because Bitcoin price has grown quite substantially over that time. The most interesting thing in the past few years was the shift of a lot of the hash rate to the US, North America more generally, but really focused in the US, West Texas and Midwest and the Southeast, wherever people can find low cost power. A lot of that is in West Texas with solar and wind. And then Bitcoin mining is very favorable because they can do load balancing and they can just shut in, when there's a peak demand requirement in the afternoon in the summertime, they can dial back or shut in and they can get favorable electricity pricing from ERCOT or the suppliers, because of their ability to do that and be a load balancer. But we're now at the point where after the Chinese had banned, not entirely, but had cut way back on Bitcoin mining in 2021, there was a big shift of workload to the US. And there was a lot of VC funding into some existing companies and some new companies to build up their capacity. And they now have, in the US, we now have about over 30% of the hash rate. And there are a dozen publicly traded companies that are, some of them are UK or Australian owned, but they operate primarily in the US and a little bit in Canada and a little bit in South America and some other locations. But it really is heavily US based hash rate. Just the top 4 companies are producing about 15% of the Bitcoin, and the top dozen companies are producing about 30% of all new Bitcoin, which currently is just 450 a day. And you do the math on that, it's 17 billion annual run rate. Now, we only look at proof of work coins because we're interested in supercomputing. We're interested in high performance computing. And it's only proof of work amongst all of these so-called Byzantine fault-tolerant algorithms that are used in order to have some control over the emission of the supply and control of the ledger, that use extensive amounts of compute time with many, many hashing calculations. And in the case of Bitcoin, it's this nested double SHA-256. There are other algorithms that are used for other coins. We've had as many as half a dozen on the list in the past. We were down to 2 on the last list. This time it'll be 3. The other 2 are Dogecoin. It's producing about $1 billion. And ZCash has had a big run up in price recently, so it's just going to make the cut. It's coming in around 300 million of annual production. There's a new ETF, or really it's a trust that Grayscale put out there. So that's part of the reason why the price shot up. We've had some pullback in Bitcoin pricing recently. There's some tightness in macro liquidity, mainly in the US. Chinese liquidity is good, but there's some dislocation in the repo market, the treasury market, refinancing, and there's maybe some discomfort in some of the commercial banking system. And it's aggravated by the shutdown. So we will probably need to get into next year to get past all this. We've just fell through 100,000 and bounced pretty hard there. So we're back up above. There has been a big diversification of the business plans of these companies. Most of them were pure Bitcoin mining. They're all going into hosting HPC and AI workloads. And in fact, it was just announced in the past week a $10 billion deal between Microsoft and one of the top 3 miners called IREN, IREN, headquartered in Australia, but most of their hash rate is in the US and Canada. And they got a 20% upfront payment, and this is quintupling their annual revenue, just this one deal. And they turned around and issued a contract or intent to purchase something like 2.6 billion worth of Dell-based GPU equipment. And that's just kind of typical as to the intention of this community to balance out their business plans by adding HPC and AI hosting. And they pretty much all have plans in that space. And for some of them, it's already become the larger share of their business.
So this is in part because they want to diversify, in part because they already have data center capacity. The crypto guys were pretty good on efficient cooling energy costs because that was very much part of their economic equation. So they're ready from that standpoint.
They're the most efficient providers around. They're at the frontier. They've got electricity as low as 3 cents a kilowatt. in West Texas with these allowances they get from being able to shut in. Now, they're not going to be able to do that as easily with AI workload, but they can dial up and down to some degree.
Mm-hmm.
And, they're going to, so they're appealing because of low cost. They're appealing because they're over 55% green inputs, solar, wind, hydro, some nuclear. So they're greener than the, industry at whole. So they're appealing from that standpoint. And they just have a lot of experience in developing, efficient, low operating costs. And they just need to shift the type of server from ASIC to GPU. And they go into the field, they can put it and capture methane, and flared gas and vented gas that has 25 to 80 times the impact in the CO2 equivalent into the atmosphere. They can capture that in situ, stuff that can't get into a pipeline. So they're very appealing from the sort of environmental aspect.
You mentioned Zcash kind of having a resurgence. If I recall, there were a couple of coins, now I have to test my memory, but there were a couple of few coins that were designed for anonymity, for privacy. They would use signatures to hide the addresses, and at that time, it was viewed as potentially not a good thing because you could now, in principle, do illicit activities that way. Whereas Bitcoin, it's actually pretty transparent. The pseudonymity is enough to sort of catch those sorts of things. There was also Monero, if I recall, that had similar. Why is it that Zcash suddenly got to be in the news?
Recently, Zcash has always, I think, been a little bit ahead of Monero in privacy with the zero proof capability. And I don't know really why they've gotten ahead, though. I haven't followed it closely enough, but they do have this Grayscale Trust ETF, which Monero does not, as far as I know.
I see. So they got institutional thumbs up.
Right. So we've got that with Ethereum, and we've got that, now with Zcash. But Ethereum abandoned proof of work.
Yes.
3 years ago now. And so they were very close to competing with Bitcoin in terms of annual production in our report 3.5 years ago, but now they've completely dropped off.
They vacated. Yeah. And then Bitcoin is down.
Yeah, I mentioned that. Yeah, I think it's basically macro liquidity issues. The liquidity is good globally in terms of China, and the general trend is positive, and that's supportive of all the risk markets. Bitcoin is more risk on, more trades closer in correlation to like tech stocks, not like gold. It doesn't correlate as much with gold. Gold is more risk off. But the US has got this disruption right now in the repo market, which is the treasury market. It's the short-term treasury market, the overnight loans between banks, basically, and the loans of reserves that are held at the Fed is called the repo market. And the spreads have blown out in terms of, how many extra basis points the banks have to pay. And some have now gone to the Federal Reserve window, which is embarrassing for them if their name gets out. And in fact, the Fed has been supplying the last few days tens of billions. So there's some tightness there. There's a little bit of concern about another repo crisis. All of this impacts. So that's one reason. The other reason is I think some of the big whales have just been taking the opportunity when you're above $100,000 and they've owned Bitcoin for many years, since below $1,000.
Right.
They're just taking some money off the table. So that's the other thing and some of those big sales have been tracked. You could see here's one wallet, it moved 80,000 coin, that kind of thing.
Okay, some whale activity. All right, so you mentioned SC25, the Supercomputing 25 conference is coming up in about 2 weeks, and the top 500 will be announced. One of the things I like about the top 500 is that it's not trying to be an exhaustive list of the most powerful computers. At some point, it was closer to it than it is now, but it does disclose a lot of info on the architecture of these systems. And when you do that for over 30 years that they've been doing, and you've been doing your reports, this is the 15th edition, the cumulative impact of the data becomes really interesting. So now you can go back 25 years ago and say, oh, that thinking machine CM1 or CM2 that did this, and it had that kind of architecture, and the cache was here, and the ALUs were there. Maybe I can dust off that kind of architecture and bring it back now that things have changed and some of the obstacles have been removed. And I can now implement it to do lower energy, AI. So it has tremendous value from that standpoint. And it also has some predictive value, because after you look at it for a while, you can see a machine architecture and say, oh, I think this will be good at this and not good at that, sort of a thing, in terms of matching the algorithm to the system. So looking forward to that. In the run-up, a big piece of news was from Department of Energy. Department of Energy has been driving the latest, greatest supercomputing in the research world, and in fact, really driving the industry non-trivially as well for a very long time. And a few years ago, Oak Ridge National Lab became the first site that could do 1 exaflops, that's 10 to the power of 18 floating point operations in 64-bit precision. If you drop it to 8 bits or 4 bits, you can get a lot more performance, and that becomes AI performance rather than just kind of traditional supercomputing performance. So there was a bunch of anticipation on what they would do next. Last week, it was announced that Oracle and NVIDIA will be building a system for Argonne National Lab, 2 systems actually, with something like 100,000 GPUs in one, and a jumpstart one that will show up sometime next year with 10,000 GPUs. And then HPE and AMD will build one for Oak Ridge National Lab, also a really big one. Actually, Steve, if you're a little up to speed on that, you can tell us what they're doing.
Yeah, this is a public-private partnership of around $1 billion with AMD and HP Enterprise and Oracle. And at those 2 labs, Oak Ridge in Tennessee and Argonne in the Chicago area, the ones at Oak Ridge, first half of 2026, it's an AI factory for science, energy, national security workloads. And the second one is 2 years out, beyond that, 2028, 2029, which will be next generation, higher capability. And then at the Argonne site, and they've actually given names for these, it's Lux and Discovery and at the Oak Ridge, Tennessee site, and it's Solstice and Equinox at the Oracle and NVIDIA partnership at Argonne National Lab. And it'll be 100,000 Blackwells and then 10,000 GPUs in the Equinox system. It's 2,200 exaflops, which is 2 zettaflops. And basically, they're trying to reduce deployment times so that they can measure them in some number of months instead of years. Trying to span both HPC and AI, and also use AI to run HPC-like algorithms as well.
Yeah, that's a really good way to see it, that HPC is enabling AI and then using it.
How is that working out? Because the codes generally aren't built for using the low precision arithmetic, right? I mean, that's been the problem, that if you want to do the traditional HPC codes, they don't run well on the current generation GPUs. Have we basically got to the point now where we have new algorithms which don't need that are optimized for running on GPUs, or are we, what's happening there?
Well, I would say core algorithms, no. I mean, they do require usually 64, sometimes 32-bit floating point accuracy. But what AI allows you to do is to do the optimization part and to run front-end optimization screen over a very high dimensionality space for design of experiments. And then, you drill down with your traditional HPC code in the way you focus.
They're also working using low precision arithmetic to get high precision results through iterative methods and come out ahead. And one way they do that is by using low precision to get close to the answer, because you're just trying to get to the neighborhood of the answer. And maybe low precision is good enough to get you there. And then once you get close, you switch to high precision to get to the final answer. And then even in that zone, you could use iterative methods to get to that high precision through low precision arithmetic if the analysis shows that you can come out ahead. I've tried to find a way to describe this. One way I'm experimenting with is vertical precision and horizontal precision. You can either allocate 64 bits and do it, or give me 4 bytes and I'll just iterate my way to it and eventually get to the same kind of a thing.
Yeah, this is the analog to mesh refinement. So, if you're running a fluids code around a complex aircraft, then you need to have mesh refinement at the key edges and so forth,
Yes.
where the turbulence is getting high, right?
Sharp corners, right? Yeah.
And so this is somewhat analogous to that, where you've got this, but it's not a three-dimensional space. It's a very high dimensionality space that you may want to be searching because you've got many parameters, in this design of experiments approach.
That's an excellent analogy.
Actually, Shaheen, a point we brought up a few years ago was that the cost of building custom chips for specific purposes has actually, and the ability to do it has sort of democratized out. And one of the things we thought might happen was that people would build supercomputer specific chips that were just focused on, 64-bit vector performance, right? Like Fugaku or whatever, right? Are we seeing more generations of those appearing? Is that something you'll see at sea, or is that happening? Or are people just saying, well, there are so many GPUs out there, we'll just figure out how to use those?
I do. And I think consistent with what we said, and in our tradition of being several years ahead of the market, the advent of tiles or chiplets and 3D packaging is enabling that. And I think that has a ripple effect through the whole industry that shall be felt over the next few years. But one thing that it is enabling is to have HPC optimized variation of your chip or AI optimized, because you really could envision that you've got a menu of chiplets that you can go click on, crudely speaking, and out comes a chip that is more optimized for this. I can say, I need 3 of those 64-bit units and like 10 of these 4-bit units, and I need 2 radios. And, now I cut like a cell phone version of the chip. In fact, the announcements of DOE included an HPC optimized version of an AMD chip. It's like MI430X or something. So I believe it is starting to show up that way. You still are going to need some volume. So I don't think you're quite to the mass customization point that concept points to, but you are getting some of that customization. Now, one of the things I mentioned earlier about dusting off older technologies is data flow architecture, which has been around for decades and decades. And you had actual systems in the 70s and early 80s. And I personally used one, the ENS Evans Sutherland PS300 graphics workstation. Was a pretty high-end vector parallel, but it was a data flow architecture. So computation would happen when the data was arriving, very streaming kind of a model. That architecture is also relevant to FPGAs and reconfigurability of the technology that you have. So they kind of dovetail together. So if you focus on FPGAs or you focus on data flow, and if you kind of use those words half interchangeably, then you can say that Samba Nova already uses some of those principles. Grok uses it in some of those principles. Even traditional GPUs have similar concepts that they incorporate. Next Silicon, an Israeli chip company that's been not so stealth, they announced their GPU that is a data flow architecture. And they have a compiler that matches the code, turns it into a flowchart basically, and then maps it to the ALUs that they've got on the chip. And of course, as a result, you can actually get better and better as you run the code and the patterns emerge, and they do it in near real time. That's really interesting to watch. The other thing that came up that I want to mention was at the GTC conference that NVIDIA had in Washington, D.C. last week. There were a bunch of announcements, but one that was notable to me was they're taking $1 billion equity in Nokia. Nokia and Ericsson and Huawei and Cisco and not many others are like building 5G switch backend chips. People like Qualcomm and Huawei and others do the handset version of that. So they cut a deal with Nokia to put AI into the radio access network, which is sort of the part in the middle between a handset and the backend core. It's the RAN, radio access network, that connects the two together. And crudely, you can think of it as the telephone poles. Now, imagine if you could ask yourself, does every telephone pole need half a dozen GPUs in it? And if you say that, then it's easy to see why Wall Street would be interested in that. But there's been a whole bunch of stuff happening over the past decade or so to make this ripe and credible at this point. One of them, way back when, was the idea of software-defined radio access network, SD-RAN. Okay, so that softwareized a whole bunch of things. And then you had Open RAN, ORAN, that modularized it and laid the groundwork to say that, oh, if I'm essentially working with servers in the cloud or the telephone pole, then those servers can now benefit from AI, and AI means GPU. And that led to AI-RAN, AI-RAN, which is another consortium and technology that injects it into this modularized software-defined world. So all the pieces are now coming together. Now, if you imagine that you're a telco operator and your 5G going to 6G backend really benefits from the capabilities that it offers you, you're upgrading your own infrastructure for your own use. But now that you've got essentially a server on every telephone pole, maybe you could do other things too. Maybe you could have other applications or services. So you could envision that this could really usher in a whole new way of thinking because it brings compute to the fabric in a big way. We had a podcast with Chris Walker, our ex-Sun colleague. This is a few years ago, talking about IoT and video processing and how the endpoint watching your backyard connects to the cloud and where you need the GPUs and what the issues were. So the concepts have been around for a long time, is my point. And it's kind of interesting to see that it's starting to happen in a big way. All right, so that was a notable thing. Anything else, or is that a good time to conclude this episode?
Is there some quantum developments that we haven't talked about?
Oh, right. This is why this podcast wants to be like one of those multi-hour ones that people like. Google announced some interesting results with quantum computing. They claim quantum advantage with an application that is starting to kind of look less useless, because initially it was just a muscle exercise with quantum computing, and quantum advantage came about by making sure that the quantum computer runs a random set of instructions that it's supposed to. And then you take those same things, put them on a classical computer and say, oh my God, this takes 30,000 years, even though nobody would ever want to do it. And then if you really want to do it, there might be other algorithms that could do it faster in a classical way too. It's not the same algorithm. As quantum computers claim to have exceeded the performance of classical computers, that is a recurring issue. This happened to D-Wave when they claimed quantum advantage, and it's happening to Google now that they have. So to date, nobody has managed to beat a cluster of GPUs with anything useful, but they are inching forward. And I think one of the challenges of quantum computing, as we've discussed before, is that every milestone is actually pretty significant from a scientific academic standpoint, but it's not a whole lot closer to the destination. And you need a lot more of these breakthroughs to actually get there. But the applications are starting to get a little bit more real, and I think that's interesting, or the kernels starting to be more real. And then DOE actually had, and then government had a whole quantum fund for science that has been kickstarting this area as well, putting some more public money in it. Even in the US, there's a lot of private money in there. So they just upped that again by having a $625 million commitment to advancing quantum computing in the US, and also put out a challenge to the industry to create a early stage, they called it, early stage fault tolerant quantum computer, FTQC, by 2028. That's very ambitious. We shall see. Because I think when you look at roadmaps of various vendors, you're still looking at 2035 plus or minus a few years if there's a breakthrough before you can have like a real quantum computer that does something real. But you never know, because breakthroughs can happen unpredictably. Good. On that note, I suppose we're concluding this episode. Sound okay?
Okay, thank you.
All right, gentlemen, thank you. Thank you, Adrian. Thank you, Steve. Thank you, Chris.
That's it for this episode of the OrionX Download Podcast. Every episode is posted to orionx.net and shared on social media. Use the comment section or tweet us with any questions or proposed topics of discussion. If you like the show, rate, review, and share it. The OrionX Download Podcast is a production of OrionX. Thank you for listening.